Imagine this. You're pushing your thumb against a balloon. Can you feel that? The force pushing back against your thumb? That, my friends, is pressure at work. Pressure is the force applied per unit area. It's like when you're trying to squeeze onto a crowded bus. The more people there are, the more pressure they exert on each other. Now, let's talk about how we measure pressure. We measure it in units called Pascals, a term named after the scientist Blaise Pascal. A single Pascal is a very small force acting on a tiny area. Picture a mosquito gently landing on your finger. That's approximately 1 Pascal. Moving on to liquids and pressure. Liquids, such as water or oil, comprise of tiny particles that move around freely. These particles bump into each other and anything they come into contact with, creating pressure. The deeper you go into a liquid, the more particles are pressing down on you from above. This is why a diver experiences more pressure the deeper they dive. The formula to calculate the pressure in a liquid is P equals sign RGH, where is the pressure in pascals, is the density of the liquid in kg per cubic meter, is the acceleration due to gravity approximately 9.8 ms2, is the depth of the liquid in meters. For instance, if you're standing in a pool that's 1 meter deep, the pressure at your feet would be equal sign 9,800 pascals. That's equivalent to having a small book resting on your foot. Even the air around us, known as the atmosphere, exerts pressure. Air molecules press down on everything, creating atmospheric pressure. We don't usually notice it because our bodies have adapted to it. But when you inflate a balloon, you're pushing air molecules apart, creating a higher pressure inside the balloon than outside, causing it to expand. We use barometers to measure atmospheric pressure. A simple barometer is a U-shaped tube filled with mercury. The atmospheric pressure pushes down on one side, balancing out the weight of the mercury column on the other side. Atmospheric pressure is crucial in many aspects. It influences weather patterns, aids in airplane flight, and even enables us to breathe by pushing air into our lungs. So, remember, pressure is everywhere around us, playing a vital role in our everyday lives. From inflating a balloon to the complex workings of the atmosphere, pressure is an amazing scientific phenomenon. So the next time you feel that push or squeeze, take a moment to appreciate the fascinating science of pressure.